Good evening, dear students. Today we will be discussing differential calculus. The exact topic what we are going to discuss is called mean value theorem. This is in continuation of our discussion on differential calculus. Now, before I proceed further, I just would like to take some confirmation from couple of you that you are able to hear my voice very clearly and able to view the screen properly, dear students. Would you please confirm, couple of you?
Yes, sir.
Okay, great. Thank you. Thanks for the confirmation. All right. So let us understand what is mean value theorem. Okay. So, the word mean, okay, that tells that, it is something in between. That is why it is called, the mean value theorem. Okay, so what we will be always taking that when the function is defined over an interval, we are going to take part of that wherever the function is defined, we are going to take in between any number of this extreme point of definition. So let us first try to understand one particular theorem, and then we will discuss more with a graphical representation. So dear students, the first and foremost thing what we are going to discuss is called Lagrange's mean value theorem. And sometimes this is also known as mean value theorem. Okay, Lagrange's mean value theorem is also known as mean value theorem. What is Lagrange's mean value theorem? Let us first understand. Okay, let me first place the statement in front of you, dear students. After that, we will discuss in details. The Lagrange's mean value theorem says something like this. Let fx be a real valued function defined over a closed interval a comma b, satisfying the following conditions. What is the first condition? That the function fx is continuous in the closed interval a comma b, and second condition is that f dash x exists in the open interval a comma b. That means fx is differentiable in the open interval a comma b. So if these two conditions are satisfied, then we can conclude that there exists at least one point c belongs to the open interval a comma b such that f dash c is equal to fb minus fa by b minus a. Let us understand this, this theorem by means of its graphical representation, dear students. Because if we make a graphical representation, things will be much simpler to understand. So let me show you the graph first, okay, and then I will explain exactly the result of this mean value theorem is coming into the picture. Okay. So if you look into this adjoining diagram, dear students, is that if you see this is the function, whatever you see in the blue color, that is the function y equal to fx. This is the function y equal to fx, and this function is defined over the closed interval a comma b. That means this is one point a and this is another point b. Means the function is defined over this closed interval a comma b, and that is a definition where the function is actually we are going to consider, and the function is continuous in the closed interval a comma b. The first condition, whatever I said in the previously, that is if the function is defined. After that, two conditions has to be satisfied. The first condition is that fx is continuous in the closed interval a comma b. Closed interval. What does it mean by this, dear students? That continuous, the function is continuous. That means Starting from the point A till to the point B means when you start drawing that curve, you no need to lift your pen. That is why it confirms that it is continuous. Means there is no break in drawing that graph. You no need to lift your pen to draw that graph of that function y equal to fx when you are drawing from the point x equal to a to x equal to b. That guarantees the function is continuous in the closed interval a comma b. That is the first condition. And the second condition is that the function is differentiable in the open interval a comma b. So these are the two definitions, these are the two conditions are actually satisfied. Then dear students, what you can conclude that in between a and b, as you see in that adjoining diagram, that in between a and b there is a point c, and at that point if you make a differential coefficient of fx, that is f dash c, that should be equal to fb minus fa by b minus a. You know, let me show you how it is being actually been done. Okay, so let me show you that how this is actually done. Now the point is that how this has been done. Let me explain you that if you see that fb, you know, fb is this one that if I define the function something like this, suppose this is p. This is the point Q, this is the point R. So as you see, the coordinate of the point P is what? And also let us define this point is capital A, this point is capital B, and this point is capital C. As you see, so coordinate of the point P, dear students, is what? Is actually A, comma, FA. That is the coordinate of the point A. Correct? And in the similar manner, dear students, if you see that what is the coordinate of the point B, coordinate of the point Q, coordinate of the point Q is actually B, comma, FV. Obviously, it is clear because this is the point A, and from that point A, capital, that is the point capital A, you are traversing to a distance AP. AP is nothing but the value of the function at the point x equal to a, which is fa. In the similar manner, if you see the point B, you know that from the point B, if you draw a perpendicular and if it intersects the curve at the point R, then what we can say, dear students? We can say that the function is actually intersecting the point at R, and the coordinate of the point R is B, comma FB. It is actually not Q, it is actually R. What I wanted to say, that this is the point, R. And obviously, as we get a point, C in between AB, so then what is the coordinate of the point Q? Coordinate of the point Q, what we get is that C, comma FC. Correct? So clear. So I made a small mistake while I was telling the coordinate of the point R. By mistake, I said the coordinate of the point Q. So dear students, here is the final statement. Coordinate of the point P is A, comma FA, because this point A is having the x coordinate lowercase a, and from there we go to the point P, and that is the value of the function at the point x equal to a, and we get FA. Similarly, dear students, if we get the point R, where the curve is actually the other extreme point at x equal to b, so definitely we get the coordinate of the point R as B, comma FB. And in the similar manner, dear students, we get the coordinate of the point Q as that C, comma FC. Why? Because at that point Q, if we see that if we draw a perpendicular, it actually intersects the x-axis at the point capital C, and eventually what we get, dear students, is that we get the coordinate of the point coordinate of the point Q as C, comma FC. Now as you see, this is the arrangement. Now what we are going to discuss is that what is f dash C. If you recall, that f dash c is nothing but the slope of the tangent at the point C to the curve y equal to fx. In simple term, what we can say, that if this is the point C and if we draw a tangent to the curve at x equal to C, then this is the tangent. As you see, dear students, what I am marking in the arrow. So this is the tangent. Now the slope of this tangent is nothing but a straight line. So suppose I say that this is T1, T2 be the tangent. Then T1, T2 has a slope. And what is the slope? That we know that slope is f dash c. That we know from the differential calculus, application of differential calculus. Right. So f dash c is equal to what then, dear students? That is equal to fb minus fa by b minus a. And that is also very interesting to know. If you see that straight line, the tangent at the point, a tangent to the curve y equal to fx at the point C is actually parallel to the line PR. Now, as the tangent T1, T2 is parallel to the line PR, then what we can get, dear students, the slope of the tangent T1, T2 should be equal to the slope of the line segment PR, correct or not? So what is the slope of the line segment PR? It is the difference of the y coordinates divided by the difference of the x coordinates, correct? So that is what the slope of, so what we can write is that, let me write it here, dear students, that what we conclude is that slope of T1, T2 is equal to slope of PR, correct? Now, why we are saying so? As that T1, T2 is parallel to PR. As T1, T2 is parallel to PR, what we can say is that we can conclude that slope of T1, T2 is equal to slope of PR. Now, if we see the slope of T1, T2, dear students, as I just said, that is nothing but f dash c. And what is the slope of the line PR? Slope of the line PR is that fb minus fa, that is the difference of the y coordinates, divided by b minus a. So that is exactly what is coming from the, that is exactly what is coming from, the definition from the result of the Lagrange's mean value theorem. And as I was telling, dear students, that Lagrange's mean value theorem is also, known as mean value theorem. And later we will see that there are applications of Lagrange's mean value theorem. Okay, we will see there are, good application of Lagrange's mean value theorem. I hope it is clear, dear students. So now, before I proceed to the next theorem, I just want to conclude that what is Lagrange's mean value theorem. As a few students joined in between, and I request, dear students, so please, be on time, is that, so Lagrange's mean value theorem says that let fx be a real valued function defined over a closed interval a comma b, satisfying the following conditions. The first condition is that the function fx is continuous in the closed interval a comma b. And the second condition is that f dash x exists in the open interval a comma b. So then what you can conclude, if these two conditions are satisfied, then you can conclude that there exists at least one point C in between a comma b such that f dash c is equal to fb minus fa by b minus a. Okay. Now, once our class is done, I will share the recorded video lectures of this class so that you can follow it also. Those who joined little late, they can also follow this thing. Now, let me move to the next mean value theorem, actually next theorem, that is called Rolle's theorem. And that is also a very important theorem, dear students. And in fact, we will see that, that Rolle's theorem is a special case of, Lagrange's mean value theorem. So now let us understand what is Rolle's theorem. There are several questions comes almost every year, based on Rolle's theorem. So let us understand Rolle's theorem first in details. Is that here it is, dear students. So Let fx be a real valued function, okay, defined over a closed interval a comma b, satisfying the following conditions. The first condition is, the function is continuous in the closed interval a comma b, and second condition is that f dash x exists in the open interval a comma b, and third condition is that fa equal to fb. Okay. Now here there are three conditions. Okay. The first condition is that the function fx is continuous in the closed interval a comma b. What does it mean, dear students? It means that when you are drawing that curve of that function y equal to fx from x equal to a to x equal to b, you can draw that curve smoothly without lifting your pen. That means there is not a single point of discontinuity of that function y equal to fx from x equal to a to x equal to b. And what is the second condition, dear students? That f dash x exists in the open interval a comma b. Or in other terms, you can say that the function is differentiable in the open interval a comma b. And what is the third condition, dear students? That fa equal to fb. That means the value of the function at x equal to a should be equal to the value of the function at x equal to b. If these three conditions satisfied, then what we can say? We can say there exists at least one point c belongs to open interval a comma b such that f dash c is equal to 0. Now, few minutes back I said that Rhodes theorem is a special case of Lagrange's mean value theorem or mean value theorem. Why so? Let me explain you, dear students. Think about, as we discussed in the previous page about that, mean value theorem, that is Lagrange's mean value theorem. If the first two conditions are satisfied, first two conditions are exactly matching with the first two conditions of the Rhodes theorem. What are those two conditions? If you read out that the function fx is continuous in the closed interval a comma b. That is exactly the same first condition of Rhodes theorem. The function fx is continuous in the closed interval a comma b. And what is the second condition of Lagrange's mean value theorem? That f dash x exists in the open interval a comma b, which is exactly true as the second condition of Rolle's theorem. That is, f dash x exists in the open interval a comma b. Now, as these two conditions are satisfied, then what we can conclude? We can conclude whatever the result from the Lagrange's mean value theorem. That means that there exists at least one point c belongs to the open interval a comma b such that f dash c is equal to fb minus fa by b minus c. Exactly that's what we can write. So from here we can write that f dash c is equal to fb minus fa divided by b minus a for some c belongs to the open interval a comma b. Correct, dear students? So for some c belongs to the open interval a comma b. Now let's impose the third condition of Rolle's theorem, that is fa equal to fb. Now, dear students, we know f dash c is equal to fb minus fa by b minus a. Now in this, if we write fb is equal to fa, what we are going to get? This implies that f dash c is nothing but fb minus fa is equal to 0 then. If fb equal to fa, then fb minus fa equal to 0. So 0 by b minus a. B minus a cannot be 0 because these two are distinct points. So b minus a is not equal to 0. So from here what we can say, dear students? We can say f dash c is equal to 0. So this is what we are deriving, from the Lagrange's mean value theorem, and exactly this is what has been mentioned here. Now, dear students, let us understand this Rolle's theorem by means of a graphical representation. As you know, dear students, a picture says 1,000 words. Whatever we have discussed here, if we just revisit those statements by means of a graph, it will be much simpler to understand. Okay. So keeping this in mind, so let me show you a graphical explanation of the Rhodes theorem. So what we can say is that the first thing, you look into this particular graph, dear students. So if you see this particular graph here, as you see, is that let the graph come. Yeah, it came. As you see, dear students, so this is the function y equal to fx. Let me write down this thing. So this is the function y equal to fx. Now in this function, as you see, that the function is continuous in the closed interval a comma b. The function is continuous in the closed interval a comma b. That is, the a is the one point and another point is the b. That means what? From the point A till the point B, sorry, from the point A till the point B, if you draw the curve, you no need to lift the pen. You no need to lift the pen when you draw the curve from x equal to A to x equal to B. Okay, dear students. Okay, so from x equal to A to x equal to B, you no need to lift the pen. That is the first condition is satisfied. The function is continuous in the closed interval a comma b. And the second condition, dear students, is that if f does x exist in the open interval, f does x exist in the open interval a comma b. So then what we see, dear students, what we see is that the two conditions satisfied. And third one, very important, that if a equal to fb, that means whatever the value of the function at this particular point and what is the value of this function at this particular point, both the values are same. Suppose this particular point is p and this particular point is q and this particular point is a and this particular point is b. Then what you get, dear students? If you see PA is equal to QB, correct or not? So what we say is that PA is equal to QB. That implies what? That implies what is PA? PA is equal to nothing but the value of the function at x equal to a, that is nothing but FA. And what is QB? QB is nothing but the value of the function at x equal to b. So that means that is nothing but FB. So what we get, dear students? FA equal to FB. Now as we get this thing that FA equal to FB, what we get is that if that c is equal to 0, there exists at least one point c belongs to the open interval a comma b such that f dash c is equal to 0. And that is what is the Rolle's theorem. Now there is one point I would like to emphasize. What is mentioned? There exists at least one point c. There exists at least one point c belongs to a comma b. That means what? It may possible that there exists more than one point in between the AB. And how it is? Let me show you by means of a graph so that it will be more helpful to you to understand. So look into this particular graphical representation, dear students. Okay. If you look into this particular graphical representation, what you see is that this function is, y equal to fx. This function, what you see, dear students, is y equal to fx. This function is y equal to fx, and what we see is that the function is defined from x equal to a, means this point, till the point x equal to b. And what we see, the value of the function at fa, which is 0 and equal to the value of the function at fb, that is also 0. Now, before that, there are two more conditions to be satisfied. The function fx has to be continuous in the closed interval a comma b, which is very true, because from the point a to b, if you draw the graph of that function, you no need to lift your pen. That proves that the function is continuous at in the closed interval a comma b. And second thing is that the function is differentiable in the open interval a comma b. The first two conditions satisfied. And third condition also, where what we see is that FA equal to 0, and that is also equal to FB. And then what we see, dear students, there are 2 points. This point is C1 and this point is C2. In both these points, f dot C1 and f dot C2 is equal to 0. How come we can say? What is f dot C1? F dot C1 is nothing but the slope of the tangent to the curve y equal to fx at x equal to C1. And we see that tangent is nothing but a parallel to x-axis. When a tangent is nothing but a straight line. When a straight line is parallel to x-axis, its slope is 0. Correct? That's why we wrote that, FA is equal to 0. That is true. But at the same time, what we can say is that f dot C1 is equal to 0. And also, what is C2? C2 is the point in between A and B. Okay. And the tangent to the curve y equal to fx at x equal to C2, that is also equal to 0. If you see, dear students, that is f dash C2, that is also equal to 0. So as these two are 0, what we can say is that we can very confidently say that there are 2 points we get here, that f dash C1 equal to 0 and f dash C2 equal to 0. Correct? So that actually why I inform this thing, just to tell that there exists at least 1 point. Means 1 point is obvious. But apart from that point also we can get another point or multiple points we can get. Oh no. Why it is so? There is another perspective we can think about this. Why there exists at least 1 point when such that f dash C equal to 0 when f equal to fb. Let me help you to understand, dear students, by means of a pictorial diagram. Look at this function. Let me draw this function once more, the first function, and explain you that why f dash C has to be 0 when fa equal to fb, along with the 2 other conditions satisfied, that the function fx is continuous in the closed interval a comma b, and the function is fx is differentiable in the open interval a comma b. If you look at this one, suppose the function is actually, dear students, if you see, the function is started defining from here, that x equal to a. You started going up. Then, now if you need to come back to the another point b, such that the value of the function is same, then definitely you need to turn out this function, right? You need to turn down. It go up and then again it has to come down. At that point where it is turning, at that point definitely the tangent to the curve at that point has to be 0. The slope of the tangent to the curve. Let me clarify very clearly. The slope of the tangent to the curve at that point x equal to c has to be equal to 0. And that is what is happening here. So why? Because the value of the function at x equal to a, that is fa, that is nothing but fa, dear students. Now the value of the function at x equal to b, that has to be fb. Correct? So that means once function is going up and again you need to come at x equal to b, then it has to come down. Otherwise it is impossible to have fa equal to fb. That is one thing. In the similar way, you can think when the curve is something like this. Let me draw the curve in a different color. Suppose a curve something like this. The same thing has to happen. If this is the value of the function at x equal to a, means if I draw it here very clearly, for example, if I draw the function something like this. If this is the value of the function at some point, suppose at x equal to a, then at that x equal to b, the value has to be the same value, so that I can draw a straight line. So that is, so the function is coming down, and then it has to go up in order to have fa equal to fb. In this case, dear students, if you look into it, what is fa? Suppose, in fact, if we consider this function as gx, okay, so then this should be, this definitely ga, and this should be gb. Correct, dear students? Then what will happen at this point? If we draw a tangent, then what we will get? We will get it here. That is actually g dash c is equal to 0. Correct? The slope of the tangent, that is g dash c. G dash c is equal to 0. And here we get what? F dash C is equal to 0. So I just gave you a different perspective to understand that why F dash C has to be equal to 0. Correct, dear students? I hope you got a very clear idea about Rhodes theorem. Now, dear students, I am going to give you the next theorem, that is the last theorem as long as the mean value theorems are concerned, and that is known as Cauchy's mean value theorem. Okay, and that I am going to discuss in the next topic. So the Cauchy's mean value theorem, dear students, is something like this. Let me define the function first. Let fx and gx be two real valued functions defined over a closed interval a comma b. Okay. Let fx and gx be two real valued functions defined over a closed interval a comma b. If you see, dear students, in the previous two theorem, we discussed with only one function, that is fx. But in this mean value theorem, that is Cauchy's mean value theorem, we are dealing with two functions. One is fx and the other one is gx. So let fx and gx be two real valued functions defined over a closed interval a comma b, satisfying the following conditions. The first one, both fx and gx are continuous in the closed interval a comma b. Second one, both f dash x and g dash x exist in the open interval a comma b. And third one is that g dash x is not equal to 0 if for all x belongs to a comma b, then there exists at least one point C belongs to a comma b such that f dash c by g dash c is equal to fb minus fa by gb minus ga. So this is all about the Cauchy's mean value theorem. And dear students, if you take the function gx as a constant function, then you will see this is actually turning out to be Lagrange's mean value theorem. Okay. Now, dear students, as we are done with these three mean value functions, three mean values theorem, now I would like to solve some problem along with you so that it will be more clarified. Okay, then you'll understand that how how we can apply our concept of mean value theorem in solving this kind of problem. So dear students, keeping this in mind, this is the first question I'm going to solve, and I will suggest you also open your notebook and do along with me. So what is the question, dear students, here? The question is that verify mean value theorem. So this is first question, I'm marking it here. Question is that verify mean value theorem for the function fx equal to x square in the interval 2, 4. So now mean value theorem means here it is actually Lagrange's mean value theorem. So now what are the conditions to be satisfied? The first condition, let me use a different color. Okay, we see that, so the way to write, we see that the first condition is that fx is continuous in the closed interval, we can write in the closed interval 2, 4. And the second condition is that f dash x, that is the differential coefficient of fx, f dash x exists in the interval, in the open interval, open interval 2, 4. Correct? Now, as these two conditions are satisfied, okay, then what we can find it out, dear students? We need to prove that, because here we are going to verify. Okay, here we are going to verify that, yeah, it is actually, we are able to get a point between 2 and 4, so that we get f dash c is equal to fb minus fa by b minus a. So if you look into it, what is a? A is nothing but 2. And what is b? B is nothing but 4. So what is the value of the function at a? That is equal to f2. That is equal to what, dear students? 2 square. That is equal to 4. And what is the value of the function at b? fb. That is equal to f4. That is equal to 4 square. And that is equal to 16. So now, dear students, according to the mean value theorem, okay, we need to find a point C such that f dash c is equal to fb minus fa by b minus a. So according to the mean value theorem, what we can say? F dash c is equal to fb minus fa. That is fb minus fa divided by b minus a. Now, in order to verify, we need to show that this c is in between 2 and 4. How? Let's see it. What is f dash c, dear students? If fx equal to x square, if fx is equal to x square, that means what? That means f dash x is equal to 2x. That implies that f dash c is equal to 2c. So that value of f dash c, that is 2c, we are going to apply it here. So that means 2c is equal to fb minus fa. That means 16 minus 4 divided by b minus a, 4 minus 2. That implies what? That implies 2c, 16 minus 4, that is 12. And 4 minus 2 is 2. So finally what we get, the value of c is equal to, dear students, is equal to 3. And 3 is definitely belongs to the open interval 2, 4. What mean value theorem tells? Mean value, the result of the mean value theorem, that means if the two conditions are satisfied, that is fx is continuous in the closed interval 2, 4, and f dash x exists in the open interval 2, 4, then we definitely get a point C in between 2, 4 open interval, so that f dash c is equal to 0, f dash c is equal to fb minus fa by b minus a, and that exactly we got that point is C. C is equal to 3, which is in between 2, 4. Correct, dear students? So in that way, we are able to verify the mean value theorem, that is Lagrange's mean value theorem. Now, dear students, the next one what we are going to discuss, that is called the Rolle's theorem. We are going to verify one question on Rolle's theorem. Okay, and here it is, and you are going to get the question in another few seconds. And here it is, dear students. The question is that verify Rolle's theorem. The question is that verify Rolle's theorem for the function y equal to x square plus 2 when a is equal to minus 2 and b is equal to 2. So let me write it down. So what is that here? Here a is equal to minus 2 and b is equal to 2. So what is the function y equal to x square plus 2? And it is a polynomial function, right? And we know polynomial function is always continuous. So what we can say? The first condition, what we can say is that fx is continuous. Fx is continuous at the closed interval a comma b. And dear students, f dash x is what? If fx, y means here, fx means y equal to fx, by the way. Y equal to fx, and that is equal to x square plus 2. If you see the fx, that is x square plus 2, then what is f dash x? 2x. So 2x exists, so f dash x exists. F dash x exists at the open interval a comma b. Now What, along with these two conditions, another condition has to be satisfied. What is the value of the function at f equal to a? F equal to a is equal to f of minus 2, that is minus 2 whole square plus 2, that is equal to 6. And what is the value of fb? Fb is equal to value of the function at x equal to 2, that is equal to 2 square plus 2, that is also equal to 6. So from these two, what we can say, dear students? We can say that fa equal to fb. So dear students, what we see is that we see that fx is continuous at closed interval a comma b. F does x exist at the open interval a comma b, and we see that fa equal to fb. That means all the three conditions are satisfied for Rolle's theorem. Then we can conclude what is the result of Rolle's theorem. Then there exists a point c in between a to b open interval such that f dash c is equal to 0. So f dash c is equal to 0. If we assume this thing, we need to show that c belongs to a comma b open interval. That means c belongs to the open interval minus 2 to 2. So that implies what, dear students? F dash c. F dash c is nothing but if fx y equal to fx. So if fx equal to x square plus 2, that implies f dash x equal to 2x. That implies f dash c is equal to 2c. So now this value of 2c, if we apply here, dear students, so what we are going to get? What we are going to get? That we are going to get that f dash c is equal to 0. That means 2c is equal to 0. That means c is equal to 0, and definitely 0 is between open interval minus 2 to 2. So we are able to verify Rolle's theorem for the function y equal to x square plus 2 defined over the interval minus 2 to 2. So we are able to verify the Rolle's theorem. So dear students, we get a very clear idea about three theorems we discussed today. First one is Lagrange's mean value theorem. Second one is Rolle's theorem. And then finally we discuss about Cauchy's mean value theorem, followed by the two representative questions we have done. Now dear students, this is not only sufficient. What you need to do, okay, what I wanted to say is that, dear students, is that is not only sufficient. What you need to do, you need to make more practice, okay, and that I want to show you that where you need to go. So please visit www.KonarClasses.com and look for quality video lectures appear for DPPs, that is known as daily practice problems, then PTs, that is known as practice tests, then you can appear for UTs, that is known as unit test, then you can appear for MDTs, that is known as module test, and finally MTs, that is known as mock tests. And definitely you are going to get a great rank in your entrance examination and also great score in your corresponding board examinations. So and if you need to contact with us, you can always contact in this I'm going to share you my contact details here, dear students. So here it is. You can contact us as contact@KonarClasses.com, or you can call WhatsApp in the number 80950100670. So dear students, with this I would like to conclude the class for today, unless you have any specific question for me. Thank you very much, and we will have our class day after tomorrow, same time. Thank you.
Thank you, sir.
Thank you very much.
Thank you.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you very much.
Thank you, sir. Bye, sir.
Thank you.